The second lesson in our right triangles unit involves what we call special right triangles. These are two specific types of right triangles that have very special relationships between the side lengths. So our essential question is, how do I solve problems using special right triangles? All right. So what is a special right triangle? There are two types of special right triangles. We have what we call the 45, 45, 90 and the 30, 60, 90. Now these names refer to the angle measures in the triangle. So the first one is isosceles and the second one is not. Some interesting side relationships there. The relationships between these side lengths must be memorized. Okay, you will not be allowed to use a calculator for these questions. And if you have to resort to the Pythagorean theorem, it's going to take you way too much time. So make sure that you do memorize these. All right, we're going to start off with the 45, 45, 90 special right triangle. All right, and I'm going to label each leg as x in length. The hypotenuse is always x times the square root of 2. So one of the ways to remember this is when both legs are the same, the hypotenuse, so 2 legs the same, the hypotenuse is times the square root of 2. Okay, remember that a 45 and 45, 90, I guess OS, is an isosceles triangle. I always have a hard time spelling that word. And so that means both of your legs are congruent. Okay. In terms of vocabulary, you need to know both of these types of special right triangles. Let's look at the side lengths for a 30, 60, 90. Everything in a 30, 60, 90 is based off the shortest leg. Remember from the hinge theorem in your triangle inequalities unit that the shortest leg is opposite the smallest angle. So it's opposite the 30-degree angle. The hypotenuse is simply twice the short leg. It's the longer leg that's a little more interesting. That is the short leg times the square root of 3. I always had a hard time remembering which triangle got the square root of 2 and which triangle got the square root of 3. So I remember if the 2 legs are the same, that's the triangle with the square root of 2. And if the 3 legs are different, that's the triangle with the square root of 3. So remember the shortest leg is always opposite the 30-degree angle, and the long leg is always opposite the 60-degree angle. All right, find the value of each missing variable. So in number 1, I'm looking at a 45, 45, 90, and that means that my legs are the same. So x is going to equal 8. The hypotenuse is the leg times the square root of 2. So in this case, 8 times the square root of 2. For number 2, I have a 30, 60, 90 triangle. Okay, I am given 14, which is opposite the 30 degrees. That means this is my short side. So my hypotenuse is going to be twice the short side, and my long side is going to be the short side times the square root of 3. So x is 28, and y is 14 times the square root of 3. I have another 30, 60, 90 triangle. Notice this time they gave me the 60-degree information, meaning here is my 30-degree angle and there is my short side. So my hypotenuse is 2 times the short side, and my long side is the short side times the square root of 3. So x is 5 times the square root of 3, and y is 10. All right, so far these have been pretty easy because you were given the information the side links are based off of up front. Now it's going to be a little more challenging. Look at number 4. You have a 45, 45, 90. That means x and y are the same. So x equals y, which equals something, which we have to figure out. The hypotenuse is the length of my leg times the square root of 2. And now I have an algebraic equation that I have to solve. So 19 equals x times the square root of 2. To isolate x, I divide both sides by the square root of 2. And x equals 19 over the square root of 2. But I am violating the third radical rule. The third radical rule says no square roots in the denominator. So I have to rationalize the denominator, which means I multiply by the square root of 2 over the square root of 2. And that's 19 times the square root of 2 over the square root of 4. 19 times the square root of 2 over 2. So at this point, I have to pause. Can I simplify 19 halves? The answer is no, so I'm done. 19 times the square root of 2 over 2 is the value for both x and y. You knew it wasn't going to be as simple as just doing a little multiplication, right? You knew there was a way we're going to work some algebra into these. So let's take a look at the next one. It's a 30, 60, 90. And let's see, my short leg is x. That means my hypotenuse is twice x, and the long leg is x times the square root of 3. I need to solve this equation. X times the square root of 3 equals 9 times the square root of 3. To isolate the variable, I have to divide both sides by the square root of 3. And, oh, that was easy. X equals 9, and y equals 2 times 9, which is 18. Not too bad. Alrighty. Another 30, 60, 90 triangle. In this case, x is my short side, so the hypotenuse will be 2 times x, and the long leg will be x times the square root of 3. So 2x equals 32, divide by 2, and x equals 16. Y will equal 16 times the square root of 3. That one wasn't bad either. This one looks like more fun. All right, another 30, 60, 90, and this time you got the long side. So the short side on here is y, making my hypotenuse 2 times y, and my long side y times the square root of 3. So let's solve that equation. Y times the square root of 3 equals 20. Divide both sides by the square root of 3. Y equals 20 divided by the square root of 3. We are violating that third radicals rule, so we have to rationalize the denominator by multiplying by the square root of 3 over 3. That's 20 times the square root of 3 over the square root of 9, which is 20 square root of 3 over 3. Now, can I simplify 20/3? The answer is no. So I have found my y value. My y value is 20 square root of 3 over 3. My x value, I have to multiply this by 2. Well, let me come over here and do that. 2 times 20 square root of 3 over 3. Remember, we multiply by the coefficients here. So 20 times 2 is 40. Square root of 3 over 3. Pause and check. Can you simplify 40/3? The answer is no. So you are done. Aren't those beautiful answers? Radicals and fractions. It doesn't get much better. Doesn't get much better. All right, number 8 is a 45, 45, 90. and they gave me a leg. So y is 25 because both legs are the same, and x will be 25 times the square root of 2. Let's look at number 9. Okay, they gave me a 30, 60, 90. In this case, y is the shortest side, so my hypotenuse is 2 times y, and my long side is y times the square root of 3. So 2y equals 46. Divide by 2, and y equals 23. X is going to equal y times the square root of 3. And we are done. Take a moment to write a summary of the important information out of this lesson.